All right, today we're going to look and put all of our curve sketching together. So we're going to be finding increasing, decreasing, concave up, concave down, max, mins, points of inflection, all of it all at one time. So the first one is from an equation. So we've got g of x is equal to x plus 2 times x minus 1 squared. So we want to find the x and y intercepts. So obviously the x-intercepts are when y is equal to 0. So that would give us x plus 2 times x minus 1 squared equals 0. So that would give us x equals negative 2 and 1. And then our our y-intercept is when x is equal to 0. So that would give us y is equal to 2 times negative 1 squared, which would be 2. So if they're in point form, our our x-intercepts are going to be negative 2, 0, and 1, 0. And our y-intercept is going to be 0, 2. Okay? Now it says find all intervals where the graph of g is increasing and then decreasing, and then determine all relative extrema. So we need to take the derivative of this. So g prime of x is going to be x plus 2, 1, times the derivative of the second guy. Well, this is going to require the chain rule. So we're going to do 2 times x minus 1 to the first, and then we would multiply by the derivative of the inside, which is just 1. Plus, now we have our x minus 1 squared, and we multiply by the derivative of x plus 2, which is just 1. Now, I need to simplify this as much as I can. So here is one term. Here is another term. So notice that they both have an x minus 1. So I am going to factor out an x minus 1. So when I do that, that guy's gone and one of those guys is gone. So we have 2 times 1, which is 2, times x plus 2. So 2 times x plus 2 plus from that guy right there. And then now this one, we have only an x minus 1 left over. So now we want to clean up the inside. So g prime of x is going to be x minus 1 times, that would be 2x plus x would be 3x. 2 times 2 is 4 minus 1 is a plus 3. So we want to set that equal to 0 or undefined. Well, it's never undefined because that's a polynomial. So it's equal to 0 at x equals 1 and at x equals negative 1. Now we need to do a sign chart for that. So I'm going to do my little sign chart over here. So I have negative 1 and 1. So let's see, if I plug into this guy right here, my first derivative, if I plug in 0, that would be a negative 1 times 3, so that would be a negative. If I plug in negative 2, that would be a negative times a negative, so that would be a positive. And if I plug in positive 2, that would be a positive times a positive, so that would be a positive. All right, so that means I'm increasing, decreasing, increasing, and then the negative 1 will be labeled as a max, and the positive 1 will be labeled as a min. All right, the next one is determine all intervals where the graph of g is concave up, concave down, and points of inflection. So I'm going to take my g prime and find my g double prime. So I'm going to do 1, so that's going to be x minus 1, times the derivative of the second term. So the derivative of 3x plus 3 is 3, plus 2, so that would be 3x plus 3, times the derivative of the first term, which is just 1. So that means g double prime of x is going to be 3x minus 3 plus 3x plus 3. So the 3's are going to cancel out, so g double prime of x is going to be 6x. We want to know where that's 0 or undefined. Well, it's a line, so it's never undefined. So it's 0 at x equals 0. So now I'm going to do my little sign chart. I'm going to be plugging into my second derivative. So when x is negative, my derivative is negative. When x is positive, my derivative is positive. So we're concave down, concave up, and here's my point of inflection. All right, so now what we're going to do is we're going to use all of that to sketch our graph. Now, with this, the first thing I'm going to do is put my points on the graph. So I've got an x-intercept of -2, 0, and 1, 0. And I've got a y-intercept of 0, 2. Okay, I know that I'm hitting a maximum at -1, and I'm hitting a minimum at +1. And I know that I'm increasing from -infinity to -1. So I have to be increasing up here. So I'm just going to kind of draw a straight line for right now. And then I'm going to decrease from -1 to 1. That means I got to kind of come up here so that I can decrease. And then I'm going to increase beyond 1. So I'm going to come down here. Okay, so that gets my increasing or decreasing. So now we're going to talk about points of inflection. Okay, so we're going to talk and add the curvature. We have a point of inflection at 0. So to the left, we're going to be concave down. So we're going to add curvature to the graph to get our final graph. So we're going to add our curve in there. And then but beyond 0, we're concave up. So I'm going to add some curvature to that graph. And so if I go over the final graph in a different color, we're going to look something like this. It's going to be down, concave up, then switch to concave down, and then curve down like this. Okay, so that should be our graph. We hit our maximum at -1. We hit our minimum at +1. We have a point of inflection at 0, concave down, concave up. Now, what we don't know is exactly where our maximum hits up here. We could have taken 1 and plugged it into our, sorry, we could have taken -1, I guess, and plugged it into our graph and found our y value. That would have been more accurate, but I didn't do that, so that's okay. You don't normally sketch a graph of the function. Okay, so now we're going to look at one where we have the graph of f prime of x. So I'm going to build my ladder of success. So I've got to remind myself that I have f, I have f prime, and I have f double prime. Since I have the graph of f prime, that's going to be the y values. F double prime is going to be the slopes on the graph, and f is going to be the area under the graph. So if I'm looking for any of those, I know what I'm supposed to focus on. So for part A, it says find the x-coordinate of all critical points on the graph of f and then classify. So critical points are when f prime of x is equal to 0 or undefined. Well, there's no place where it's undefined because it's continuous. So that means that we want the y values to be equal to 0 because f prime, remember, are the y values. So that happens at -4, 0, and then we don't include the endpoints. Okay, so let's classify them. At x equals -4, what do we have? Our y values, if we're going to the y values, our y values go from negative to positive. So when our y values go from negative to positive, we have a minimum because f prime of x changes from negative to positive. At 0, our y values are going from positive to positive. So we're not changing sign. So we would say we have neither because f prime doesn't change sign. Okay. Now we want to know where the intervals of f where we're increasing. Well, remember, f is increasing when f prime of x is positive. So there's our justification. Now, f prime are going to be the y values on the graph. So we want the y values to be positive. So the y values are positive all the way from -4 to 6. We can either skip, we can either do -4 to 0 and 0 to 6, or we can just do -4 to 6. I'm just going to do -4 to 6. Now, one thing I haven't talked about yet, but notice that my intervals are parentheses. Err on the side of parentheses. If you're doing increasing, decreasing, concave up, concave down, you want to do parentheses. All right, now we've already done our justification up there, so that is our answer. All right, find the intervals where the graph of f is concave down. All right, so f is concave down when f prime of x is decreasing. And so that means we want our y values to be decreasing. So we want to have a downward slope. So it looks like that happens from here to here. So therefore, from -2 to 0, then we come back increasing, and then we decrease again from 4 to 6. So union 4 to 6. And we've already written our justification when we identified what we were supposed to be looking for. All right, find all points of inflection. So remember, f has points of inflection when f prime has maxes or mins. Okay, so that means we want our y values to equal either a max or a min. So therefore, that's going to happen at x equals, okay, that is not a max or a min, okay, but up here, -2 is 1, so at x equals -2. 0 is a minimum for that little piece, so 0. And then we have another one up here at 4, that's a maximum, so 4. So those are going to be our points of inflection. All right, so the last thing is if f of 0 equals 3, find the value of f of 4 and write the equation of the line tangent to the graph of f at x equals 4. So there's two things that we need. We need a point and we need a slope. So we need our point, which would be f of 4, which is going to be, that's what we want, is equal to what we have, so f of 0 plus the integral from 0 to 4 of f prime of x dx. Now, we talked about when you're finding about any information about f, remember we talked about doing our area. That's why the integral comes in. So f of 0 is equal to 3 plus, now let's do the area from 0 to 4. So from 0 to 4 is going to be this little piece right here, which is 1, 2, 3, 4, 1, 2, 3. So that'd be 12 divided by 2 would be 6. It's above the x-axis and we're going forwards, so it would be positive. So 3 plus 6 is equal to 9. Now we need our slope, which means we need f prime of 4. And remember, when we're looking at f prime, we're looking at the y values. So we need the y value at 4. So the y value at 4 is 3. So f prime of 4 is equal to 3. So then our tangent line is y minus 9 is equal to 3 times x minus 4. All right. So let's see what else we've got. I think our next one is a function defined by integral. So now we've got g of x coming into play. It's our last one. So when we have g of x, we're going to have a double ladder. So we've got g, we have g prime, and we have g double prime. Now g is the integral of f of t, okay? Then g prime is going to be the derivative of that integral, which would just be f, and g double prime would be the derivative of f, which is f prime. Now we have a graph of f of x, which remember is equal to g prime of x. So when we're talking about g prime or f, we're talking about the y values. When we're talking about g double prime or f prime, we're talking about the slopes. And when we're talking about g, or the integral of f, we're talking about the area. All right, so now let's look at our first problem. So it says find g of 0. We are given that g of 2 is equal to 1, so that's what we have. So g of 0 is going to be g of 2 plus the integral from 2 to 0 of g prime of t dt. Well, remember, that's really 1 plus the integral from 2 to 0. Well, g prime is the same thing as f. Okay, so now we're looking at 1 plus the area from 2 to 0. So from 2 to 0, we're going backwards, and our area value is going to be 2, but it's going to be negative since we're going backwards, so our y value is negative 1. Okay, if we do g of 4, we're going to do the same process. So it's going to be g of 2 plus the integral from 2 to 4 of g prime of t dt. Well, we've already said that that's the integral of f. We know g of 2 is equal to 1. So now we're going to do the area from 2 to 4, which is a quarter circle with a radius of 2. So the entire area of the circle would be 4 pi, but we're going to divide it by 4, and so we would get pi. So our answer would be 1 plus pi. All right, determine the intervals where g is both increasing and concave down. So let's put this together. So we know g is increasing when g prime, which is the same thing as f, is equal to a positive value, which means we're looking for our y values to be positive. And then g is concave down when g prime, which is equal to f, is decreasing. So that means we want our y values to be decreasing. Okay, so there's our justification. So we need positive y values and decreasing y values. So positive y values are going to be here in quadrant 1. The only time when they're decreasing is from 2 to 4. So therefore, our interval is going to be 2 to 4. And we've already justified it when we found what we were looking for. Okay, find the absolute max and min. Remember, we haven't done this in a while. There are 3 steps for an absolute max or min. The first step is to find your critical values. So we want to take g prime of x, which is equal to f of x, and we want to know where it's 0 or undefined. Now remember, that's our y values. So our y values are 0 at 0 and 4, and there are no places when the y values are undefined. So this is going to be our critical numbers at 0 and 4. Our second thing is to build our t-chart. So we have x and we have g of x. And let's see, our endpoints, they didn't give me an interval, but our endpoints are going to be -2. Then we have our 0, then we have our 4, and then our right endpoint is going to be at 6. Now, we already found 0 and 4 in part A. So 0 was -1, and 4 was 1 plus pi. So now we just have to go find our endpoints, -2 and 6. And we're going to have to do it the same way. So g of -2 is going to be that 1 plus the integral from 2 to -2 of g prime of t dt. So that's going to be, let's see, from 2 to -2, those two things are going to cancel out, so that's just going to give us 1. And then g of 6 is going to be 1 plus the integral from 2 to 6 of g prime of t dt. So we said this was pi. This piece right here, 1, 2, 3, is 4. So we're going to have 1 plus pi plus 4. So that's going to be 5 plus 5. Sorry, 5 plus pi. Then for 3, we need to write our sentence. So we want the absolute max value. So our absolute max value is, so our value, y value, 5 plus pi at x equals 6. All right, so there's finding an absolute max or min. So 3 steps. Find your critical points, build your t-chart, write your answer. All right, last thing, write the equation of the tangent line to the curve y equals g of x at the point where x is equal to 1 and use it to find a linear approximation for g of 1.2. Okay, so we need our tangent line first, so we need our point and our slope. So our point, we need g of 1, which is going to be 1 plus the integral from 2 to 1 of g prime of t dt, which is going to be 1 plus, let's see, if we go from 2 to 1, we have 1.5, but we're going backwards, so it's negative. So minus 1.5, which gives me a negative 0.5. And then we need our slope, which we would need to be g prime of 1, which would be f of 1. So we need the y value at 1. So at 1, our y value is 1. So our tangent line is y plus 0.5 is equal to 1 times x minus 1. Now, we want to approximate g of 1.2. So what we're going to do is plug 1.2 in for x. So it will be y plus 0.5 is equal to 1 times 1.2 minus 1. So if I work with this, this is y is equal to 0.2 minus 0.5, which is equal to a negative 0.3. So there is our estimated y value for that function. All right, that is it for this lesson. Curve sketching is a huge part of the AP exam. I can guarantee you're going to have at least one free response and multiple choice questions on this topic. So if you have questions, come see us, guys. Thanks. Bye-bye.